Welcome to Brain Vision.
In this problem, we have a camera at a fixed point following a race car, which is accelerating on a straightaway. And we're asked to find two things. First, the speed of the car on the straightaway in terms of the distance b that the camera is from the horizontal distance the camera is from the racetrack, and also in terms of the angle theta and the angular velocity theta dot. And we're also asked to find the acceleration along the straightaway in terms of that distance b, theta, also angular velocity and angular acceleration, theta dot and theta double dot. So when we see in terms of theta and theta dot and theta double dot, we want to be thinking polar coordinates. And so what we'll do here is we'll end up using radial and transverse components. And so we basically have 4 steps here that we'll do for this problem. So first, we're going to write r, so the radius r as a function of the angle theta. Then our step 2, we're going to find r and the derivatives of r dot and r double dot. And third step, we will find the magnitude of velocity and the magnitude of the acceleration from the velocity and acceleration radial and transverse formulas. And so in doing this, we'll get a little bit of differential calculus review. We'll need to use the quotient rule and chain rule, and we'll get a little bit of trig review. We'll need to throw in some trig identities here. Okay, so to begin with, r as a function of theta. So we can just draw this again. So we've got this radial distance r and this horizontal distance b and this angle theta between them. So we're going to find r as a function of theta, so we can say that function f of theta is equal to r, and we can write that as b over cosine theta, or alternatively as b secant theta. And so what are r dot and r double dot going to be? So r dot, so we use the chain rule there. So r dot will be f prime of theta times theta dot. And r double dot will be f second derivative f of theta dot squared plus first derivative theta double dot. Okay, and now we'll go through the calculating those derivatives. Okay, so we had r is equal to b over cosine theta. All right, and we've got r dot. It's going to be b sine theta over cosine squared theta times theta dot. Okay, now for calculating r double dot, it's a little more complicated. So first thing, we'll go through calculating that second derivative. So second derivative of this function. So we had f, first derivative was b sine theta over cosine squared theta. And so we'll take the derivative of that again. And so we'll be using the quotient rule. Okay, so have b times, numerator is going to be cosine theta times cosine squared theta. Then subtracting derivatives, we'll have a sine theta and a 2 cosine theta and a minus sine theta. Okay, all of that is our numerator, and our denominator is going to be that cosine to the 4th theta. Okay, so that's our f, so our second derivative, and we can simplify that into we're going to have a b, and we'll have a cosine cubed theta plus a 2 sine squared theta cosine theta, and cosine to the 4th in the numerator. All right. And we can simplify further. So we're going to have a cosine squared plus 2 sine squared theta. And so we've canceled out a cosine term. So we'll have a cosine cubed theta. And so we can use an identity here. Cosine squared plus sine squared is equal to 1. And so we'll simplify that a little further into b sine squared theta plus 1 and divided by a cosine cubed theta. Okay, now we can get that r double dot, since we've calculated the most complicated part of that expression. So r double dot is, and again, is equal to that f second derivative theta times theta dot squared plus first derivative f and theta double dot. And so that's going to be equal to our, so second derivative we just found, b sine squared theta plus 1 over our cosine cubed times that theta dot squared, and plus, we got that first derivative is b sine theta over a cosine squared theta times our theta double dot. Okay, so now we've got expressions, we've got our expressions for r dot, and r double dot. And now we're ready to move on to our part 3, which is finding the magnitude of velocity and magnitude of acceleration from our formulas for radial and transverse. Radial, and so we'll have an r and a theta. So we'll be working in polar here. Okay, so part A, we're finding magnitude of velocity. So our formula for velocity in radial and transverse is going to be an r dot in the radial direction plus an r theta dot in the transverse direction. And then, so we can just calculate we want the magnitude. So that's just the square root of the component squared. So it'll be so we'll have an r dot squared plus that r theta dot squared. All right, so we're going to get for our magnitude of velocity. So we'll have a square root term, and let's see, so our first term is going to be that r dot squared. So we'll have a b squared sine squared theta over a cosine to the fourth theta and a theta dot squared. And then our second term will be a b squared over cosine squared theta and times a theta dot squared. Okay, so we've got the square root of all of that. And we can simplify this a bit. So we'll factor out a b squared theta dot squared over cosine squared theta. And then we've got a sine squared over cosine squared, which of course is tangent, plus 1 in there. And we can simplify, and we can, let's move on. And so we can write that as a b. So we'll have a secant 1 over cosine. So we'll have a secant theta, b secant theta times a theta dot and square root of tangent squared theta plus 1. And this is all simplifying a bit more because tangent squared plus 1 is equal to secant squared, another identity. And so we get our speed, so the magnitude of velocity, is equal to be theta dot squared times secant squared theta. So that's our expression for the speed slash magnitude of velocity for part A. And part B. So we want the magnitude of the acceleration. And so we're going to so we have a formula for that with its radial and transverse components. So we have our r double dot minus our r theta dot squared in the radial component, and then the transverse component is an r theta double dot plus 2 r dot theta dot. And so, and again, we'll do that same thing where the magnitude is equal to the square root of the component squared, radial squared, and transverse squared. Okay, and these are a little more complicated, so I'll just go and calculate the AR and the A theta, and then figure out how best to simplify them to put them together under a square root. All right, so our AR, okay, so it's that R double dot minus R theta dot squared. And so that's going to be a B sine squared plus 1 divided by a cosine squared theta. Or, sorry, that should be a cosine cubed theta plus a B sine theta over cosine squared theta. See, theta double dot. See our R, this is our R double dot. And right. And so that should be see, double dot. Oh yeah, this has a theta dot squared, and then we're subtracting that r theta dot squared, and that's going to be a b over cosine theta and a theta dot squared. Okay, so we've got these three terms. We've got two theta dot squareds and one theta double dot. And all right, we can combine all these terms. And so we'll factor out, let's see, first we'll do the theta single dot, theta dot squareds. So we'll have a b over cosine cubed. Let's see. This, yeah, so b over cosine cubed theta. And so we'll factor, so we'll have this sine squared theta and b theta dot squared. Okay, so sine squared theta plus 1 and minus, so we'll turn this third term into a, that will turn into a cosine squared theta, which will help us to simplify. And then that theta double dot term remains the same, b sine theta over cosine squared theta, theta double dot. Okay, now, so we'll get, we'll have a sine squared plus a 1 minus cosine squared, so that's a 2 sine squared there. So now we've got 2b sine squared theta over cosine cubed theta, and that's our theta dot squared term, and we've got that b sine theta over cosine squared theta double dot. Okay, so that is our a sub r, and we could leave it there, but as we'll see when we do the transverse component, we can simplify this a little bit further in a way that will be helpful. So we'll factor out a tangent and a secant. So b tangent theta secant theta, and so that leaves us with 2 tangent theta theta dot squared and plus theta double dot. Okay, so this is going to, this form will be similar to the form that we'll get for a sub theta. So that will make our calculation of the magnitude of acceleration simpler. All right, now we're calculating our a sub theta. And so a sub theta is equal to r theta double dot plus 2r dot theta dot. And so that is going to be a b over cosine theta theta double dot plus 2b sine theta over cosine squared theta, theta dot squared. And we can factor this out. We can factor out a secant. And so that'll give us a b secant theta and a theta double dot plus 2 tangent times a theta dot squared. Okay, and so we can see that we have in our a sub r, we have this 2 tan theta, theta dot squared plus theta double dot, and in our a sub theta, we've got that exact same term. So that is going to make the calculation of the magnitude a little bit simpler. Okay, so that magnitude of acceleration, again, equal to the a sub r squared plus a sub theta squared. All right, so our a sub r, and see, so we've got a b. Let's see, so our a sub r is the tangent theta secant theta, because a b squared tangent squared secant squared theta, and our 2 tangent theta theta dot squared plus theta double dot. Okay, so that's our a sub r, and then our a sub theta squared is going to be b squared secant squared, and then our 2 tangent theta theta dot squared plus theta double dot. Okay, so that's all our square root term. All right, and so we can, all right, so that's going to simplify quite a bit. So we've got our tangent theta, yeah, these are both squared, so we'll be factoring that out, and we'll just get a term in front, which is a theta double dot plus 2 tangent theta theta dot squared. And inside our square root, we're left with a b squared secant squared theta, and we have a 1 plus tangent squared theta, and so we'll use 1 last trig identity again, so that 1 plus tangent squared is secant squared. And so now we've got our theta double dot plus 2 tangent theta theta single dot squared, and so times a, it's left under our square root is just b squared secant to the 4th theta. Okay, so we'll get rid of that square root. So we'll simplify here, and so we've got a b secant squared theta, and that other term is our theta double dot plus 2 theta dot squared tangent theta. And so that is our magnitude of our acceleration vector.